Thank you very much. Thank you very much for inviting me. It's a bit of a long list, actually. Having wrote that myself, I realised that there's quite a lot of stuff that's going on at the moment. Just a little bit more information about where I'm coming from in this. I'm a contractor with the Digital Catapult. I'll explain about Digital Catapult in a minute. But my background is actually mostly in building performance. So it's understanding, as we all understand here, why you design to do one thing and you operate and it does something else, and there's a whole load of stuff that happens in the middle that we're really trying to get to grips with. My background is I was with Innovate UK for 5 years. I ran their built environment programs, mainly the BPE, the Building Performance Evaluation program. And what I do now with Digital Catapult is taking the findings from that activity, the causes and the main challenges within in the industry for the performance gap, and how we can apply these new and emerging technologies to try and address some of those issues. So what do we do at the Digital Catapult? The Catapult is part of 10 catapults within the network. We're partially funded by government, mainly through Innovate UK, partially funded commercially. And the Digital Catapult is here for advancements in technology in 4 key areas. That is mainly artificial intelligence, machine learning, future networks. So future networks includes 5G technology, low power wide area networks for communication, Internet of Things. We also work within the immersive or extended reality, depending on what your terminology you use. So that's virtual reality, augmented reality, mixed reality, and distributed ledger technology, which is the fancy name and the correct name for that demon, which is blockchain. And I will be touching on blockchain very, very slightly, but we only have 15 minutes, and so introducing blockchain into any conversation is full of mines. So we will casually scoot on past that, but we will be touching a little bit on blockchain. So the Digital Catapult works with industry, and I'm the built environment specialist who's focusing on particularly how these technologies can work within the built environment. So what is the real problem at the moment? What are we actually faced with as an industry and as specialists within the field? The biggest challenge is actually, it's not what is happening, it's the speed of change. It's the speed of things that are happening, which creates a kind of inertia a lot of the time within the industry. And so if we see how the built environment has changed over time, we repurpose things, we adapt things, we have existing infrastructure which we have to bring up to date, and we have to bring new technologies in. The challenges we have to look at now really is that we need to stop being quite so tech-centric and be more challenge-centric. What are we actually trying to address? What are the scenarios that we're trying to work with? And how are the technologies that are available to us able to address some of those scenarios? At the end of this presentation in a few minutes' time, I'll be going through some different scenarios which we look in terms of building simulation and building performance, and seeing how we can apply some of those technologies in order to make those situations more productive, easier, more efficient, and much easier to be able to address in a more cost-effective way. But before we go into all that, I think we need to have a quick check on the current state of the art on these 4 technologies that I talked about: AI, immersive, Internet of Things, or future networks, and distributed ledger technology. So let's start off at the moment with AI. Now, AI is an advancement on machine learning. Machine learning is based on algorithms. Artificial intelligence is a base algorithm which will update and which will learn over a period of time. I bet most of you have had some kind of interaction with AI pretty recently. And that could be either using your phone, using facial recognition, could be phoning up a helpline and talking to a chatbot on a helpline. These are all examples of artificial intelligence which are being very prevalent and coming into the world now at the moment. Now, the key thing about artificial intelligence is that, as I said, it has the ability to learn, it has the ability to adapt, it has the ability to take new information, apply it to the existing information it has, and come up with new conclusions. Now, this is an interesting one. You probably have heard over the years that you've had artificial intelligence that has won games of chess, or has played a game of Go. It's a Chinese game which is incredibly complicated, and artificial intelligence, not connected to any kind of internet, not connected to anything at all, as a single standalone machine, can win at these games. Again, the American game show Jeopardy. I'm not sure it's terribly popular over here, but the premise of the game show Jeopardy is that you get given an answer, and you have to ask the question which corresponds to the answer that's given. So it's a bit of a back-to-back quiz show. Now, the artificial intelligence again won at Jeopardy. It was given an answer and was then able to correctly pose the right question in order to be able to answer that. Now, that's fine. I mean, that's okay, because they're fairly straightforward things. The question has an answer, or the answer has a question. That's a factual thing. The really interesting bit is the poker chip. Now, last year there was a machine called Liberatus that was developed in a university in the States, and it won $1.7 million real money in a game of Texas Hold'em with 8 of the best Texas Hold'em poker players in the world, and it won. Now you say, okay, so that's a game, that's fine. But the important thing about that, and the important thing to realise with the state of the art now with AI, is that in poker you cheat. You lie, you cheat, and you deceive. And that's a really important thing. So the machine learned how to bluff. It learned the potential of the other person within the game that will also be bluffing. And that's a massive shift. That's a huge shift in AI, the way that works, because it's not a linear result. So if we start looking at future networks are kind of the things that are around us all the time. You don't really pay that much attention to it. But what limits most of the adaptations in technology now, or the uses of technology now, is actually the amount of data, the weight of data that we have. We're generating so much data time. The people who were doing the presentations earlier on, the amount of information that you had to crunch, the amount of information, the different tools you had to use in order to get that information from point A to point B, different systems. We're almost having a challenge with the weight of data, the physical weight of data. And what we have a problem with now is if you're actually using some of these technologies in anger, if you want to use them on site, if you actually want to use them as proper design tools or proper iterative tools which are not office-based, you want to use them on the fly on site. It's the shifting of data between those 2 points. That is the problem, that we are unable to shift this stuff. So this is where 5G technology will come in. The fact we have a much better capacity to start shifting information from one point to another. Or you can start looking on building sites where sometimes you don't have very good communications at all. And those communications, you then start saying, okay, well, let's start looking at micro-communications. Let's start looking at lightweight, low-power, wide-area networks. So you can start pushing light bits of data, fairly common pieces of data, over short areas of short distances with a low-power network. And that low-power network is important because, again, you can start connecting these devices directly to this low-power network, bypassing the internet in its entirety. And then, of course, you've got the Internet of Things, IoT, the concept which is prevalent now. People are saying, okay, well, we'll connect everything to IoT. People have it in their homes, Alexa, all that kind of stuff. That's all IoT-based. Now, IoT will becoming really interesting when you start looking at it at tracking and tracing. How you can track materials, how you can track provenance of materials through a supply chain. And we're not just talking at the moment about sensors or RFID tags or QR codes on materials. We're now looking to the point in saying actually you can get sub 2 millimeter dust almost that you can start putting on materials. It's powered by kinetics, so it's powered by movement, and so you can start tracking almost anything. Because the challenge when you start tracking materials through and it has a tag on it, what if you're tracking steel, for example, through a supply chain, and you have a 6-foot piece of steel and it gets onto site and somebody chops a foot off the end of it, and that's the bit with a tag on it. So when you start seeing away the prevalence of IoT and how we can start tracking and tracing materials through a supply chain or tracking things throughout a building, the technologies now for these micro tagging and micro tracking is getting really quite important. So the technology most people are probably aware of is immersive XR. I won't go into the detail of immersive technology. It's fairly common, people really know about it. But there are other elements to immersive technologies at the moment, which is 3D audio and haptics. So it's all well and good where you can start visualizing a building, putting on a headgear, putting on an immersive mask, and looking internally at your building. But what about the sensory perceptions of hearing? What if you change the acoustic properties of a room? How can you tell that? If you're designing an office or designing a building which has an open plan feel to it, how can you ensure that the acoustics within that building are actually beneficial to the health and well-being of those individuals? So 3D audio now is becoming more important, and also haptics. So that is the physical sensation of touch or the physical sensation of heat. We can start doing that with acoustics. You can start putting out micro sounds which help you with feeling the physical feeling of something within a room, and that is really important when you start saying, okay. And the last one is the dreaded one, distributed ledger technology or blockchain. Now I'm not going to go into any detail on blockchain, really not going to go into any detail on blockchain at all, just to say it is a method of accountability which is changing from a centralized authority, as in an organization who has power over your information, to a decentralized system where you have groups who are collaborative in sharing that information, and it's self-managing. Distributed ledger, blockchain, powers Bitcoin, all that kind of stuff. It's just code. Don't get overly excited about it. It's just code. And it will tend to come into the industry over the next few years, but will be delivered really from a software and a vendor point of view. So you probably won't even know that you're utilizing it. It is important, though, when we start looking at the concept of trust. And the concept of trust is what we'll come into in a minute when we start looking at a couple of scenarios. So there are two scenarios here I thought we would just go and see how some of these technologies can really start influencing the way that we will work or the way that we will design in a virtual way at the moment. So from a design perspective at the very beginning, we're looking at, we had conversations earlier on, we had presentations on people using parametric design. That's also can be generative design. How do we use artificial intelligence to start learning from design, learning from the mistakes that have gone before, learning from the benefits of previous designs, and pushing that forward. One of the challenges with building models is that they're not always entirely accurate, and they're full of unconscious bias. When you start having designers and engineers coming in to start looking at these systems, the unconscious bias will always come in. You've done it before, it's worked before, so therefore let's do it again. With generative design and AI, you can start getting rid of some of those challenges. And so you can then go through huge amounts of information very, very quickly to come up with the optimal designs. And those optimal designs will be given to you rather than you deciding what those optimal designs are. Visualizations will become increasingly important. I mentioned earlier on about the haptic feedbacks, but you can start then visualizing energy flows. One of the outputs that we found from the work with Innovate UK is that the energy literacy within the construction sector and in the design sector, and amongst architects, is not particularly great. And so you can start using these technologies, you can start using the immersive technologies in order to start informing visually about how the energy flows around your building are going to be working. And again, you can start doing that as well. You can use haptic feedback to actually feel heat, feel drafts, feel the way a glare will work or a solar gain will happen if you're sitting in front of a glass window. We can start modeling and mapping that. And that's a really powerful tool. And what we want to try and do is, and again, going back to the stuff that was illustrated earlier on, is that we have all these different pieces of software which are all trying to plug in together, trying to shift data around. What we want to actually try and be able to achieve is using that immersive environment to actually do the design. You design within that immersive environment. You design within that scenario. And this goes back again to the challenge of shifting data. Once we get the problem of shifting huge amounts of data from point A to point B, you can then start doing iterative design within the immersive environment. And then finally on to Internet of Things and blockchain. As I mentioned here on, is that we can start tracking materials and goods through a supply chain, but the key point in this as well is it's not just physical materials or physical goods, it's data. So we can actually track who is using specific pieces of data with any kind of supply chain or with any kind of design scenario. And again, we've had it earlier on in the earlier presentations, people using specific metrics for glare or for solar gain. Are those numbers being consistent throughout that design process? Where are those numbers kept? If you can keep it on a ledger, keep it on a distributed ledger, and track that through a design process, then you know that everyone is using the same information. And then at the end of it, you'll come up with your digital twin. So the digital twin is actually really important now. And what we need to try and do over the period of transformation with construction is start getting the value into that digital twin. At the moment it's being created, but nobody really uses it. It's like it just seems to happen. So what we're trying to do now is actually say, okay, use the digital twin at the end. Use it to optimize your building. Use it in order to create preemptive maintenance. Use the feedback. Use artificial intelligence, distributed ledger, sensor networks to A, make your building better, but then also get your client and customer relationship better. How can you allow your client to start interacting with the building more? And using these various technologies so they can self-manage. And then finally, in-use maintenance based on information using the digital twin. Start pulling information from the digital twin in order to allow you to start doing maintenance in a more effective way. Now this is a really, really basic example. This is using a HoloLens, which is a mixed reality system which produces holograms. And this is a leaking tap. So that's the HoloLens. You stick it on your head. And this is what you can see. So you can see the pipe runs. You can see where things are going. It's superimposed, it's 3D into the real environment. So you can actually, in this circumstance, all he's looking for is the stopcock. That's all he's looking for. But he knows exactly where the stopcock is because it's pulling information from the digital twin. He can take off the ceiling panel, he can turn off the tap, and before you know it, you've got that leaking tap. It's just that efficiency. But the key thing there is it's driving value from the digital twin scenario in the first place. It's driving value from that building model, which is the bit that we're missing at the moment. You create it, but we're not providing the value for it. And the last one, promise this is the last one, is the culture of change. So the people, and I go on about this all the time, most of the work I do is focused on people rather than technologies. It's how people can adapt. And I always maintain that we have analog people and digital people. Now, they're not split by age or gender or location. It's purely based on the fact that how can you instill a sense of trust and instill a sense of enthusiasm when people's jobs are changing around you. And we have to be very aware that a lot of people are actually analog people. They're not digital people. And we have to work with them to bring them forward. So thank you very much.